Because what happened to people who continued on that members are cyclosporin compared to the other members. Would be interested in knowing that rather than looking at people who had chronic allograft from they were converted to everolimus versus people who did not have any problems with they want protocol therapy with the everolimus. Because here it means that patients are doing well, who did well, continue to do well, and will change. Patients who didn't do well, even when you change. That's what it implies overall.
Have you compared your everolimus group versus the people who would continue on the regular immunosuppression? That's one question. The other question is, when you had projected one slide, death depiction, you said it's statistically significant. I feel the groups are too small in number. One number is 27, another number is 12. One death in 27 amounts to about 3%, and two in 12 amounts to about 16 or whatever it is. So I think the number should have been taken into consideration before you project the statistics. Questions from the audience, please.
What is the other protocol, other than the protocol you converted to everolimus? What is the reason? Is it CNA toxicity? You compare one group protocol to the other group.
It's like when someone active toxicity, someone had MMF induced bone marrow suppression, so they wanted to.
So, why the difference in the outcome? In the protocol biopsy, you showed an improvement, whereas in the other group, there is no improvement at all. Both in the other part of the country. Could you explain that?
Because in the other group, the renal dysfunction has already started, and despite the unnecessary everolimus, there could not be reversed. Probably it's because of these patients were on prolonged calcium inhibitors, so probably that's the reason for the continued decline in renal function.
It's not to make comparison. We just had to compare the group with everolimus. Good people who are continued on, they have got the answer at the time. Now, people who did people who didn't do well, irrespective of change.
So you should compare with everolimus control group like this.
Sure.
There's no more questions at you. Thank you.
We move on to the next paper. This is the speaker is Dr. Ismail Kumar from AIMS Kochi. He's going to speak to us on the influence of death.
Professors, teachers, and my dear friends. Today's paper, I try to do something with nuclear medicine and renal transplant. So this study is on the influence of death assessment on GFR by renal scintigraphy in renal transplant discipline. This is from Mehta Institute of Medical Sciences, Kochi. Now, as we know that GFR assessment is important in donor pre-transplant evaluation, also in the recipient in the post-transplant status. And the major advantage, it is a non-invasive modality that provides the GFR of the single kidney. Disadvantage being it's available only in specialized centers and it's expensive. Now, we see in this picture, this is the patient lying in. On top of him is the gamma camera, and this is the distance of the gamma camera from the patient, and this patient is undergoing a DTPA renal scintigraphy. Now let us look into some technical aspects of this. Now if you try to understand the renal scintigraphy, now this is the graft kidney and this is the gamma camera. One of the major determinants of the GFR calculation is the distance of the camera from the graft kidney. Now, why am I talking about this distance? Now, as the nuclear material is taken up by the kidney, it emits radiations, and this radiation is taken up by the gamma camera. So, the distance of the gamma camera also determines the illumination of the nuclear material, and thus it uses a software which is known as GATE software and converts this images into a formula GFR which we obtained from this lab. But if you see one small fraction of this distance is the distance of the graft from the surface of the skin. Now this fraction which is shown in the red line, it can vary. How? Because this variation depends upon the graft bed dissection. It also depends upon the surgical placement of the graft and the abdominal muscles or pad of fat which the recipient develops in the post-transplant period. And the intensity of the images taken by the gamma camera depends upon the distance of the object of interest. What is the object of interest? Is the graft from the gamma camera. But we have seen in most of the nuclear medicine labs, they use this distance mostly fixed. This fixed distance is applied into the GATE software to compute the GFR. Now, how this idea struck to us when we went into the original paper which was published in Journal of Nuclear Medicine way back in 1981. This was a paper by Gates, and in this paper he had mentioned a formula in which he had introduced the depth of the gamma camera to the graft kidney, and this depth was fixed and was being used over the course of time as a fixed number to the formula. So what was the problem is we were getting sometimes false glomerular filtration rate, sometimes higher, sometimes lower. That is because the distance of the graft from the skin of the patient was actually varying, as we saw in the previous slide. Now we can say that this distance is not a big deal. We can also calculate it by, because the patient will be undergoing ultrasound anyway. But ultrasound, if you look carefully, ultrasound when we apply the probe on the abdomen, this amounts to some pressure on the abdomen, and this pressure also reduces the depth and gives a falsely low depth or low distance of the skin from the graft kidney. And definitely there is always an intra-observer variation from person to person who is doing the ultrasound. So for these reasons, ultrasound may not be the best modality to check the depth of the engrafted kidney from the skin surface. So CT scanner, yes, it can give an accurate depth assessment. So what we try to do is, we measure this exact distance of the gamma camera to the surface of the grafted kidney using a CT scanner and apply this depth into the GATE software in reverse scintigraphy and try to obtain the GFR. And we also obtained a GFR through a traditional method using the fixed distance. So now we have two GFRs. One with the distance which we did using a CT scanner, and other one was our old traditional method using a fixed distance. So with these two GFR, we wanted to compare each other. We tried to compare it with one standard value. We used the estimated formulas. We used MDRD equation and CKD-EPI equation and tried to see that which of these two GFR, with the depth or without the depth, correlates better with the MDRD or the CKD-EPI equation. So the aim of our study was, our protocol is to do DTPA GFR at 6 months after post-transplant in the recipient. So our aim of the study was to determine the GFR of the allograft at 6 months after transplantation in the recipient by DTPA remogram using the exact depth of the surface of the engrafted kidney from the skin surface, and to compare the GFR obtained with the exact depth and without the depth assessment, and correlating both with each other and also with the MDRD and the CKD-EPI equation, which one is a better GFR for our use. So we have 20 live-related donor renal allograft recipients, and we used technetium 99M11 diethylene triamine pentacetic acid renal scintigraphy, which was done at 6 months after renal transplantation. Our mean age of our patient was 39.5. We had 18 males and 2 females. Using, as I already explained, that using a CT scanner, we found the depth of the engrafted kidney from the surface of the skin, and this distance was fed into the GATE software program, and we also obtained it with the fixed depth, which was previously being used as a standard depth. And then we, both the GFR were compared with CKD-EPI equation and MDRD equation. We applied Charles-Person coefficient of correlation and independent sample t-test using SPSS version 20 software with each other and also with the estimated formulas. So this is the result we obtained. Now when we look into the mean GFR using the standard depth, that is our traditional method, in which we found that the mean GFR was coming as 46.21. But when we applied the depth using the CT scanner, we found that GFR was 39.09. So we had two different values. So were they similar or different? When we applied the statistical analysis, we found that both were statistically different. So both are different values. This was our first point. Then what we did is we tried to correlate both these GFRs with NDRT equation. As we see in this graph, this is a correlation analysis graph. Now if you see carefully, this is the R value. The R value closer to 1 correlates better. R value farther than 1 correlates less. So when we use with no depth, the R value is 0.5. But when we use depth, R is 0.7. That means it correlates much better. Same thing happens when we use the CKD equation. R value is 0.7, so it correlates better. So what we found is the GFR of the graph between the depth assessment correlate better with MDRT equation, and also the same thing applied when we try to do with the CKD equation. An additional finding which we found was this graph GFR by fixed depth assessment actually overestimates the one which we compare with the measured one. So the measured one is better. So we conclude that standard depth input may lead to overestimation of graph PT GFR, and GFR obtained by the GATE software using directly measured depth of the allograft from the gamma camera correlates better with the estimated GFR calculated by MDRT and CKD equation. So there was some limitation to our study. We had a very small group. We need to translate into a larger group with a larger population, and there may be some residual linear function of the native PT which may contribute to the calculated GFR by the MDRT and CKD equation, which may be better if we use a well counter. So the depth is always in the deep depth of the ocean and depth of each study, each topic, then only we'll find the treasure inside it. Thank you.
Before going on to the discussion, not only for the graph but also for the native techniques. In fact, the center where we scan is done outside, but we have considered a form where we mention the depth of the loads done by our form. We do mention the right thing is so much compared to the parasite area, the left thing is so much in the misinterpretation for that technical scan. Routinely done for the last 6 months.
Any questions from the audience?
I should compliment you, but it's a known fact. I mean, if you ask any nuclear medicine fellow, you will get a higher GFR. You'll ask me what GFR you want, he will fix it depending on the. I think you have done a good thing, but what is new in this?
So the new thing is this, that we are able to find a GFR using a CT scanner. Now this depth assessment is not done in most of the labs. If we use this depth, we can reach a better GFR or a closer GFR. Obviously we need a better standard or the better control. This control may not be the MDRT equation because of the constraint. We can have a well counter which can check the levels of this inner nuclear material every 2 hours for 6 counts, and that will correlate better. So this we are trying to get a well counter for that.
So I have a suggestion. We try this. Try eliminate this in normal people. Use GFR, use a CT, and then you correlate. You have got a standard, and then you can apply. It's very difficult because there are a lot of variables as you said, your limitations, scientifically, and then you are using it with CT. So it varies, and it varies even in the make of the type of the isotope scanner you use.
Thank you.
I have a question. See, it's easier to assess the depth by ultrasound. You have done in your study with the CT. Don't you think there is an additional radiation exposure and the practical feasibility of
low dose radiation. So we have a PET scan in our nuclear medicine labs. This has a low dose radiation which can only see the image of the kidney, may not identify all the architecture inside the kidney. So it will be good enough to give us the distance from the camera to the graft kidney. It's a low dose screen.
Any questions from the audience? There are no questions. We move on to the next paper. This is outcome of missing donor renal transplantation, single center